Here is an example that will help get you thinking about expected values. Let's say you are given a choice between a certain $5, you are just given $5, or either $0, nothing, or $10 based on the results of the toss of a fair coin. In other words, you get nothing if it comes up tails, and you get $10 if the coin comes up heads. Which would you choose? Now, part of this problem will depend on whether you are a little more of a risk-averse person, in which case you're a little more likely to take the $5, which is certain, or a risk taker, in which case you might take the $0 or the $10 based on the results of the toss of a fair coin. But in either case, we are going to compare the expected values in each case. Now, the expected value for part A is pretty easy, because you get the certain $5, so the expected value is $5. But let's figure out the expected value in part B. Let the random variable x denote the winnings in part B. The probability mass function of x is f of x is equal to 1/2. That is the probability of winning $0. And 1/2 is the probability of winning $10. This is a discrete distribution. Its two mass values are 0 and 10, and each of those two mass values are equally likely. So when we calculate the expected value of x, we write mu, or the expected value of x, and because it's a discrete distribution, we have a summation here rather than an integral, and it is the sum over the support of x times f of x. Well, the support is just the values 0 and 10, so we have 0 times f of 0, which is 1/2, plus 10, the other value in the support, times f of 10, which is 1/2, and that works out to $5. So regardless if you choose A or B, in either case, your expected value is $5.